Hi, welcome to this talk about building a customer journey using domain-driven design and GraphQL. My name is Anand Chandrashekar, and I work as part of the customer success team here at Dgraph Labs. We will start with a few resources and an introduction to Dgraph. The solution for building this customer journey will be implemented using the managed services at Dgraph, and it could be worth spending a few minutes understanding those aspects. We will then talk about digital customer journeys and their relevance in the modern world. We will take an ordering journey and try to understand the nuances of that. We will then use concepts from domain driven design to model this ordering journey. We will then convert this model into a GraphQL schema and render it into dgraph. We will take a step by step journey through this ordering process and observe how GraphQL and Dgraph helps us. And finally, we will talk about dealing with changes in this journey. Let's go through some resources. The entire schema and the artifacts for this particular talk is available at the blog post DDD with GraphQL over at dgraph.io. If you want to just get started with dgraph and GraphQL and go through some of the basics, you can go to dgraph.io/docs/GraphQL/quickstart. If you want to get started with the managed service, you could go to dgraph.io/docs/cloud/cloud quickstart. These resources are very useful if you want to do this solution by yourself after listening to this talk. Let's have a quick introduction of dgraph. What is dgraph? Dgraph is a native GraphQL graph database. Let's parse that statement. Dgraph is a native graph database. What that means is that it does not work as a virtual layer over some RDBMS or columnar or any other kind of store. Dgraph manages its own storage. The technology that goes into managing this storage helps it become very fast and is highly scalable. Dgraph also is a native GraphQL database. What that means is that developers who are familiar with the whole GraphQL style of development can really get started quickly. They could take a schema, give it to dgraph, and then straight away start using the CRUD APIs. This helps to build your apps much faster. Dgraph is an open source database, and you can go over to GitHub and explore it yourself. Great, now let's start with the customer journeys. Let's now talk about digital customer journeys. The modern customer expects to use their products as part of their daily lives. For example, you may be in the kitchen and running out of milk, and you would want to order milk via a voice driven app. Similarly, you may be meeting a friend at a park and you may want coffee delivered at the park. What does it take to build these type of journeys? Well, these type of journeys heavily rely on customer feedback. We cannot rely on traditional waterfall methods of development. The reliance on feedback leads to an iterative style of development. And if you look at each iteration, a bunch of stuff changes. Of course, some elements in the UI can change, but the area where the developers face a lot of challenge is the changes around data. So there's always some new fields being added, some additional process aspects being modified. An example could be a customer may want self-service options for payments and returns. The changes that are happening in these type of situations lead to a lot of refactoring in the code. Developers take a lot of time to update the data model as well as the data services around the data model. So what that means is that you may have a database, and when new data needs to go into this solution, you would need to update your database, and then there will be some kind of CRUD API which will also need to get updated for this data to enter and exit the system. This is where GraphQL shines because it allows you to declare your schema via the GraphQL schema capability. And with dgraph, you don't have to really go and change anything at the backend. Dgraph takes the GraphQL schema and directly creates the GraphQL API. Well, that's good that we can increase our speed of development by simply managing a lot of data related changes in the schema alone. But that still leaves certain aspects that are continuing to challenge the developer. For example, just having a new CRUD API, it may not solve the problem. There is also the business process layer that needs to be updated. Remember the self-service option as an example that we took. It's a part of the entire ordering journey. And the ordering journey as a whole is not one entity, it's actually a collection of entities. So, how do we handle the bindings between the process layer as well as the CRUD API or the data layer? Again, there are some aspects of GraphQL that we will evaluate that helps us to optimize this type of binding and address it via GraphQL. Now, one another aspect that you may want to note is that this entire ecosystem often works around a mesh of API driven apps. You take your voice processing API or any other location type of API. These APIs tend to work on JSON. GraphQL is a popular option as a API standard as well. So they both go well hand in hand. And that's where GraphQL solution or a GraphQL centric approach to the digital customer journey goes well with the other parts of the ecosystem. Right? With that said, let's begin discussing some of the modeling aspect. Now let's understand the ordering journey that our customer wants to take. The ordering journey has an ordering process. This process at the moment when we are starting this development consists of four steps. There is submit, where the order is submitted by the customer. As part of submission, the ordered item and the quantity will be provided. At the next step, we will acknowledge the order. Then we need to ship the order. There may be a location to which the order needs to be shipped. Then we will create an invoice for the order and send it to a customer. This is a small example of only four steps that we are using to get started with this example. Now, at a high level, you can already make out certain important entities in the domain. These are the customer, the product, the order, and the order process as well. How will we go about creating the model for this? In what way can we think about the data layer for this type of process? Well, let's borrow some techniques from domain driven design. The box that you see is the focus of your development. You, as a development team, get to decide what goes inside the box, what is your focus area. Once you have some idea of what you want to model on, there are a few things that domain driven design will tell you to consider. Well, first thing is the box itself. You must identify what is important to you. So that box is called a bounded context. Within this bounded context, your developers, your business users, and other team members might be operating. So you need to have clarity in the communication within your team. There should be no ambiguity when you say acknowledged or shipped inside your team. So, from domain driven designs, nomenclature, or concepts, one aspect called ubiquitous language is very important to consider. The ubiquitous language concept says that you must have a common mechanism and agreed mechanism of naming things, and those names should be interpreted consistently within your domain. Another way of thinking about it is that if a word like ship or product may have different meanings in different contexts, you need to construct the ubiquitous language within your domain such that the ambiguity is removed. This may seem very silly for small projects, but as the number of projects explode in your enterprise, a clean mechanism of managing this ubiquitous language can be a force multiplier in the speed at which you can execute the projects. So, what do you think the focus of our bounded context should be? Well, why not the business process itself? Remember, we did mention that the business process changes often. This is the part that will have to be refactored several times. What if we keep the process itself as the focus area and drive all the other artifacts, such as the schema, the API, from this central view of the process, right? That's what we are going to try. So in this example, we are taking the business process, which has the steps of submitted, acknowledged, shipped, and invoiced as central to our bounded context. Of course, the other entities like the items, the customer, all of them will make their appearance, but they will be discussed as part or in the context of this business process. This helps us to also maintain a ubiquitous language so that whenever we talk about, say, an email address in an invoice, it is always interpreted in that context. We will create the GraphQL schema in such a way that this context is reinforced within the team. So what that means is whether you are a backend developer or you are an API developer or you are a front-end UI maintainer and developer, you will all have the same understanding of the attributes, the process involved. Now, let's look at what we are exploiting in the GraphQL world to achieve this. Well, in the GraphQL schema, we have types and interfaces, which is very commonly used to model real world elements. Since our focus here is just not the type alone, like a customer or an item, we will consider creating a union called order journey as our focus area. Now, this union will be a collection of types. The types here will be nothing but the steps involved in the business process. For example, the types submit order, acknowledge order, ship order, invoice order, all will be part of this ordering journey. These steps may all have some common elements, things like, say, a version or a last updated. All of them will be captured in a common interface called order journey element. The beauty of this in the GraphQL schema is that you can maintain all of these process oriented aspects as part of the schema, so the process is sufficiently expressed for your entire team to collaborate. The other advantage is that there is a clearly defined or area where to add new steps. Finally, with a database like dgraph, you can generate the entire backend for this. So all you're going to do whenever you are going to maintain this and deploy this is deploy a schema. Dgraph will look at the types, the unions, and generate the API for you. You will straight away get a GraphQL API, which your clients, whether they are people who are consuming GraphQL API as a data service or a UI developer who's consuming it in a React based application, can start to build their respective artifacts. Let's head over to dgraph cloud and look at this schema in a bit more detail. So here I'm opening the query order process, which is a query API for the order process, just so that you can explore the fields that you can pull back from the backend. Remember, as a front-end developer, you will have access to this type of view. So you will always look at this API specification whenever something changes or whenever you are looking for a certain information. This API signature in the GraphQL API acts like a reinforcement of ubiquitous language between the front end and the backend teams. Let's see how. So when I open this query order process, I will skip the filtering. Let's straight away go to what we can pull back. An ID for this process can be pulled back. Things like the channel and the item data, like the product and the quantity, those can be pulled back, right? So these are some important order related items. But let's now look at the really interesting part here, which is the related process. I'm going to go to the related process and open the process step. Now, when I go into the process step, I can see the process steps associated with my API clearly called out. So when I'm a client, I'm a UI developer, I know that I can pass a submitted by node only in the context of an order. And hey, look at this. What is this? It's a customer, right? So there's no ambiguity of where a customer appears or what is the most important area for a customer in the context of the entire business process, right? So customer, as you might expect, is very important in the context of submitting an order and providing some information like a customer address and name. Similarly, there's acknowledgement. Shipping is interesting. Shipping has a shipping address. So this could very well be that a customer is registered with a certain address but may want to ship the order to some entirely different address. And it's now specifically called out that a shipping address is a different field. This again reduces the confusion so that people understand that, hey, is the address to be shipped to a customer address? No, because we are specifically calling it out here. So it's something that the API is expressly telling its clients that you need to refer to shipping address in the context of a shipment. Similarly, here is a preferred email address in the context of invoicing. So a customer might want the invoice to be sent to a particular email address. This is not to be confused with, say, a email address for sending marketing or product update information, right? So as you can see, the fields appear in the context of the business process. And as I mentioned earlier, this is a great way of enforcing a ubiquitous vocabulary of whatever your business process entails. It helps the backend and the front end to have a common understanding. And finally, of course, when you do any changes, those changes will appear as part of this updated API signature. You will actually be doing some changes to the GraphQL schema, which we'll see later in the talk in order to handle changes. But your front end will be informed through this API signature. This helps to maintain a continuum of ubiquitous vocabulary even when changes occur during the development of your solution. I'd request you to go through the schema available at the blog site here. This will help you better understand the finer aspects of this schema. We'll now go through a step-by-step journey of this demo. I've taken the liberty to create some reference data. So here are a few customers and here are a few products. The IDs of these customers and products will be used in our schema and used in our process. So now let's go through a step-by-step journey. Let's first start this journey off by adding a order process from an online store. Here's a product that we need. I'm going to copy the ID. I'm also saying that the quantity is 10. Great. So some information is set up. Let's also start this process by submitting. As part of this submitting, we will need to specify the customer ID. So here's the customer ID. Great. Let's also remember to pull back the order process ID. We'll be using this ID throughout the demo. Great. Looks like our order has been created. Let's now quickly step through the other steps of this process. So I'm going to clear this mutation. I'm going to update this order process for the other steps. So let's again start a mutation. I'm going to update this order process. I need to pass this ID. So we have now successfully passed the ID. Let's also set the changes we want to do. So in this case, we want to acknowledge the order. And let us pull back the ID like before. Great. Now we've again acknowledged this same order. So we've actually gotten past the second step. Now let's go to the last two steps. So next is the shipping. So I'll again clear this out again and start a new mutation with the update order process. Let's again pass the ID. Let's again set the shipping details. So in this case, shipping address. Great. That should do it. Let's update the shipping. Fantastic. So we again updated the shipping for this order. And finally, the last step is invoicing. Let's set some billing address and the email address for the invoice. All right, so we've set up some data for the invoicing as well. All right, done. So we've now completed the entire process. Now let's review this entire process through a query. Let's conclude the example with a review of the order we just created. Here's the order. Here are the details of the order. So first is the channel. There's the product name and description and quantity. Finally, you will see the process steps as well as the data associated with each step. So here's the customer details for a submission. Here's the acknowledged tone. Here's the shipping address and the billing related details. All of the data is available here on the right. With this, we've concluded the example. As a final part of this demo, let's now go through a change in the entire process. So let's now go back to our schema. Here's our GraphQL schema. As mentioned in the blog, we are going to add a process step. Let's assume that a customer is demanding that they would like to return the order and use a map location where the order can be picked up from. Let's go ahead and model this additional step called return order in our GraphQL schema. So we're going to add a new type here. This type will be called return order. And just as the other steps in this order process, we are going to implement a common order journey element. Let's also ensure that we add the details associated with the return. So one of them is a reason, which can be of type string. We will make it mandatory. And we'll also provide a pickup location, which will be of type point. Right. So we've created this return order type. We'll also make it part of our business process by adding it to the order journey union. Right. So now we are saying effectively that the order journey has an additional step, and that step is associated with the reason for return as well as pickup location. Let's deploy this schema. Great, the schema has been deployed. We can now go to the API Explorer and review this updated API. Let's go back to our query order process. And now if you see the process steps, you would see a additional return order available here. You can go into the return order and pick the reason as well as the latitude and longitude of the pickup location. With this, we have managed the change in the ordering journey by making a focused change to the schema. Dgraph takes care of creating the backend associated or updating the backend for this new schema. It also provides you an updated API. Your front-end teams can now consume this API and continue building their respective items. This concludes the talk. Thank you.